welcome everyone to another session with Dr. Sidhu, who is a researcher and certified and licensed AP chemistry teacher. Today we are going to continue with our topic with measurements and calculations with Dr. Sidhu. Dr. Sidhu, how are you today?
Hi Komal, it's nice to see you. I'm very much fantastic today.
That's good. So let's get started, Dr. Sidhu. Um, Define the term temperature.
Of course. So the next topic after the dimensional analysis, you remember the last time we discussed about the dimensional analysis, how to use that concept to solve the various problems. So today, the new concept we are going to start is the temperature. So what do we mean by temperature? This is a very common word which we basically hear. But what basically the temperature is in chemistry, how it is defined. Look, in layman language, we can see the temperature is basically the degree of hotness or coldness of a body. So that is known as the temperature, right? If we say a body is hot, means it is having high temperature. But if the body is cold, we say that it is having little lower temperature. So to be more technical, basically temperature is the measurement of the average speed of the molecules. So it means the kinetic energy, the speed that relates with temperature. If the molecules are randomly in motion, and they have high speed, so we'll say the temperature is high. If the molecules are having low speed, so we'll say the temperature is low. Like for example, if I'm rubbing my hands like this, so what I'm doing is the molecules on the palm of my hands, basically they are in random motion. So there is a lot of motion there. So it means the temperature is going to increase. So the temperature is the measurement of basically the speed of the molecules. So that is the temperature. Yes. And we really need, there are actually 3 scales to measure the temperature.
So would you please tell us what those scales are to measure the temperature?
Yes, very commonly used scales are Kelvin, degree Celsius, we also call it like centigrade, and Fahrenheit. And all these 3 scales are related with each other. So I will give the relations, the formulas, how we can convert the degree Celsius into Kelvin, how we can convert the degree Celsius into Fahrenheit. So for example, here you can see that if we have to convert degree Celsius into Kelvin, we have to add 273.15. So degree Celsius temperature plus 273.15, and then we get temperature in Kelvin. And if we have to convert temperature into Fahrenheit, what we need to do is we will multiply by a factor of 1.8. So 1.8 multiplied by the degree Celsius temperature and plus 32, and we are able to get temperature in Fahrenheit. So these are the 2 ways we are able to convert the degree Celsius into Kelvin. And of course, we can reshuffle these. Like for example, if you have to convert Celsius into Kelvin, we will be using this formula. But if we have to convert Kelvin into Celsius, of course, we will be subtracting 273.15. So it means the students need to know how to reshuffle the various variables to get the desired units for that temperature. Now, how these 3 scales are related with each other. So look how beautifully I have drawn these 3 scales here on this paper. So you can see that, give me 1 second. This is, yeah. So on the left-hand side, there is a temperature scale that is Celsius. Then in middle, that is Kelvin. And on the far right side, that is Fahrenheit. So look, water freezes at 0 degrees Celsius. So that is the Celsius scale. And in Kelvin scale, it means water freezes at 273 Kelvin. So 273 Kelvin, that is also known as the absolute temperature or Kelvin scale. And in Fahrenheit scale, water freezes at 32 degree Fahrenheit. So look, water boils at 100 degrees Celsius. So on Kelvin scale, we can see that water boils at 373 Kelvin. And on Fahrenheit scale, water boils at 212 degree Fahrenheit. Now, the room temperature in Celsius scale is 25 degrees Celsius. And the room temperature in Kelvin scale is 298 Kelvin. And the room temperature in Fahrenheit scale is 77 degree Fahrenheit. Now, body temperature in Celsius scale, it is 37 degrees Celsius. In Kelvin scale, it is 310 Kelvin. And in Fahrenheit scale, it is 98.6 degree Fahrenheit. So this is the way the various temperatures, they are related in different scales. Like, for example, especially like in US, we use Fahrenheit. And if it is like 77 degree Fahrenheit, we say, yeah, this is very pleasant. It's not that hot or cold, right? And especially during this, uh, in COVID times. So we used to go anywhere in grocery store or in wherever, So our temperature was measured. And if it was 98.6 degree Fahrenheit, it means we are good to go. There is no fever, no COVID, right? So 98.6 degree Fahrenheit is the normal body temperature. That is in Fahrenheit. But in Celsius, it is 37 degrees Celsius. So that way we are able to relate the various temperatures.
All the scales are very important again. They are very technical, but very important as well.
Yes.
So, what is density?
Oh, of course. The next topic, which is very much important, is about the density, and is very simple. So density of any substance is defined as the amount of the mass. It is divided by the volume of that material. So mass divided by volume, that is the density of that substance.
And what is specific gravity?
Yeah, so another term which is used in chemistry is the specific gravity in some cases. So what is specific gravity? Again, is very simple. Basically, this is a ratio of the densities. So specific gravity is defined as the ratio of the density of a particular liquid to the density of water at 4 degrees Celsius. And density of water at 4 degrees Celsius is 1 grams per milliliters. So that's basically the ratio of the densities of that liquid and water. So what we think about the unit of specific gravity? Of course, there is no unit because the density is in the numerator and density is in the denominator. So there is no unit for specific gravity. So in other words, we can say that specific gravity is a dimensionless quantity, because those quantities which are not having any units are called dimensionless quantities.
Thank you so much, Dr. Sidhu, for sharing this information with us. I hope the audience is getting all the technicalities that you are sharing. I hope you all are getting educated and benefit from our sessions in the future. We are going to hold these sessions for you as well. Please like and subscribe Dr. Sidhu's Academy on YouTube. This is your host, Komal from Mountain Media, signing off.